Okay, at what points are the tangents to the circle x squared plus y squared minus 4x minus 6y plus 9 equals 0 parallel to the x-axis? Write down the equations of these tangents. Okay, so you might recognize this from AS. Okay, this does represent an equation of a circle. Okay, and we need to find the tangents that are parallel to the x-axis. Now, if you remember about tangents, okay, that's referring again to the gradient. Yes, so if we get the gradient of the curve, or the circle in this case, then we can find a tangent at a particular point. Okay, because the gradient of the curve will be the same as the gradient of the tangent at that point. So we need to work out the gradient function, right? So we'll differentiate with respect to x. Okay, so we're going to differentiate implicitly. So x squared becomes 2x, y squared becomes 2y, dy dx of course, because it's a y term. Minus 4x becomes minus 4. Minus 6y then becomes minus 6 dy dx. And then plus 9 is 0. And on the right hand side you get 0. Okay, so there's no product in this case. Nice and straightforward. Now what you might notice now is that we've got a common factor of 2. Okay, so we can divide by 2. So we have x plus y dy dx. Take away 2. Take away 3 dy dx equals 0. So if we then factorize, group together the dy dx terms and factorize, so we have y there and this one then be minus 3. So you multiply out, you get the terms we have here. So we just factorize out the dy dx, take the other terms over the other side, so minus 2 goes over, becomes a plus 2, take the x over, becomes a minus x, and then you have dy dx is equal to 2 minus x over y minus 3. Okay, now we need to think, okay, about what it means when it says parallel to the x-axis. Okay, so if you think about your x-axis, right, get a ruler here. The x-axis, of course, is horizontal. Okay, that means your tangent, if it's parallel to the x-axis, is also going to be horizontal. If your tangent is horizontal, what can we say about dy dx? Okay, well, if it's flat, horizontal, of course, dy dx and the gradient, because it's flat, the gradient is 0, isn't it? So we could say, since tangents are parallel to the x-axis, the gradient of these will equal to 0. In other words, dy dx must be set to be 0. Okay, so there's our function for dy dx, our expression there for dy dx. This has to be 0. Now when you have a fraction equals to 0, that means the top, think about it, what must the top be if the fraction is 0? Well, of course, the top then must be 0, yeah? The bottom can't be 0, because you can't divide by 0, it become infinity. So the top has to be 0, yeah? 0 divided by the bottom will be 0. The other way, of course, you could think about taking the y minus 3 over the other side and timesing by 0, so it just disappears. So the top must be left then to equal 0, which means then that x will equal to 2, okay? So that's the coordinate, or the x-coordinate, where the tangents are parallel to the x-axis. X will be 2. You then need to work out what the y value will be. Okay. Now, think about how we're going to work out the y value. All right. Of course, we could go back to the curve, can't we? Okay, because x will be 2. We can substitute it in here and see then what y is going to be. So sub into the circle equation, so we'll have 2 squared for that's what x is, yeah. So x squared, 2 squared plus y squared. Take away 4 times 2. Take away 6y plus 9 is 0. Okay. So if we simplify this, 4 plus y squared minus 8 minus 6y plus 9 is 0. So we get y squared, take away 6y, plus 5 equals 0. So what have we got? Of course, we've got a quadratic, haven't we? Yeah? A quadratic here in y. And we can factorize the quadratic to work out what our y value is going to be. So there's going to be more than one y value in this case, okay? So factorize, we need to think of two values that multiply to give 5, add up to give negative 6. Well, two numbers that multiply to give 5, you can only have 1 and 5, yeah? Because 5 is a prime number. To get them to add up to give minus 6, they both need to be minus. So therefore, y minus 1 is 0, or y minus 5 is 0. So y will equal 1, or y will equal 5. Okay, so you have 2. Okay, so we have 2 points. The point will be when x, obviously x will always be 2, y is 1, and the other point is going to be x will equal to 2 again, y will equal to 5. Okay, so how does that look if we were to draw that? Now remember, we're dealing with a circle, yeah? So it's just, this is a circle equation, so let's just see what it would look like. And it's obviously focused around the point x equals 2, yeah? Now I've got my little circle drawer, okay? At the point x equals 2 there, okay? Well, the tangent then, obviously I haven't drawn this to scale, we've got fy was 1, wasn't it? And the other one, y was 5, okay? So the tangent, because this parallel with the x-axis, is going to look like that, and then the one up here is going to look like that. So, what equations can we give these? Well, of course, when the line is horizontal, we just write down the value that it goes through on the y-axis. So we say y equals to 1 and y equals to 5. So those are the tangents there for our circle. Okay, horizontal lines will just be y equals in both cases.